From lightening the bulb, running heavy industries and ships, to the treatment of diseases, nuclear reactors have been important in the list of human inventions. In this video, let's discuss everything about nuclear reactors. A nuclear reactor is a system that allows contained nuclear chain reactions. The reactions in a reactor produce thermal energy through nuclear fission or nuclear fusion. This energy is then used in electricity generation, organic research, or ship propulsion systems. Nuclear reactors can be found all over the world. They contribute to 11% of the total world electricity. In this era, where every country is looking to replace unclean conventional power generation, nuclear reactors have been a prominent choice due to their clean and environment-friendly behavior. The research in nuclear technology began back in 1932 with the discovery of the subatomic particle, neutron, by British physicist James Chadwick. The concept of a nuclear chain reaction was first realized shortly thereafter by Hungarian scientist Leo Szilard in 1933. However, Szilard did not incorporate the idea of nuclear fission with a neutron source, since the process was not yet discovered. His ideas for reactors using neutron-mediated chain reactions and light elements proved unworkable. The inspiration for a new type of reactor using uranium came from the later discovery in 1938. It was discovered that the bombardment of uranium with neutrons produced a barium residue due to breaking down or fissioning the uranium nuclei. This discovery was done by Lise Meitner, Fritz Strassmann, and Otto Hahn. The design of reactors has undergone major improvements for efficiency and safety since the adoption of nuclear power on an industrial scale. The evolvement of nuclear reactors can be divided into 5 generations. Generation 1 reactors existed from 1950 to 1970. They were the first to produce civilian nuclear power, for example, the reactors at Shippingport in the United States and the Calder Hall reactor in Cumbria, England. The powers of these reactors seem modest compared to the ones being used today. Generation 2 reactors existed from 1970 to 2009. Their need was felt after the 1974 oil crisis. About 85% of electricity produced worldwide by nuclear power comes from second-generation reactors. These heirs to the 1950 to 1960s prototype. About 439 such reactors have been deployed today. Second-generation reactors belong mainly to 2 families of light water reactors: pressurized water reactors or PWR, and boiling water reactors or BWR. Generation 3 reactors are based on developments of Generation 2, incorporating improvements in the design developed during the lifetime of Generation 2 nuclear reactors. These include improved fuel technology, superior thermal efficiency, significantly enhanced safety systems, and standardized designs for reduced maintenance and capital costs. The first Generation 3 reactor to begin operation was in 1996. Generation 4 reactors are still under development and are expected to launch by 2030. Generation 5 reactors are purely theoretical and are not the subject of intense research. Today, there are 454 reactors being used for power and 226 reactors for research. Most of these reactors are either pressurized water reactor or boiling water reactor. Most modern reactors work under the theory of water pressure. From our primary school, we know that the boiling point of water decreases with the decrease in pressure. This is the reason why cooking at high-altitude places like mountains takes more time. This is because the water boils at a lower temperature, thus failing to impart the required heat to cook. On the other hand, if the pressure on water is increased, the boiling point increases too. Hence, cooking food is faster on lands near sea levels, since increased boiling point makes the water hold higher thermal energy before it gets evaporated. A pressurized water reactor works in a similar manner. The primary coolant, that is water, is pumped under high pressure to the reactor core, where it is heated by the energy released during the fission of nuclear atoms. The heated high-pressure water then flows to a heat exchanger, where it transfers its thermal energy to lower-pressure water, converting it into steam. After transferring its energy, it is resupplied back to the reactor to gain thermal energy. The steam generated in the heat exchanger drives the turbines, which spins an electric generator, generating electricity. The steam then condenses into water, which again participates in the cycle. However, in a boiling water reactor, demineralized water with neutron moderator is pumped into the reactor core. This water absorbs the heat energy released due to the nuclear fission reaction and turns into steam. The stream is pressurized and sent to run the turbine, which generates electricity. The pressure in steam decreases as it exits the turbine. This low-pressure steam is passed through a condenser, which converts the steam to water and completes the cycle. The condensed steam is reused, and the cycle proceeds. Pressurized water reactor and boiling water reactor together form the most percentage of reactors active today. The main difference between these two reactor types is that in case of a boiling water reactor, the reactor core heats water, which turns to steam, and then drives a steam turbine. But in pressurized, water under high pressure is heated so that it can hold the heat beyond its boiling point, as the boiling point of water increases with an increase in pressure. This high-pressure hot water then converts the low-pressure water to steam, which runs the turbines. Producing electricity is an important use case of nuclear reactors. Nuclear energy is clean, and electricity generation from nuclear fuel is more environment-friendly than gasoline or coal. Nuclear reactors are also used to power propulsion systems in ships and submarines. The Nimitz-class and Ford-class aircraft carriers of the U.S. Navy and Charles de Gaulle of France are based on this principle. Other countries like India and China have active plans for nuclear-powered aircraft carriers. Nuclear reactors generate tremendous amount of heat energy. This heat energy can be used in industrial process or in district heating. District heating is a centralized heating unit from which heat is transferred to other places using insulated pipe. This is often used for residential and commercial needs. District heating helps in better pollution control than localized heating boilers. Some nuclear reactors are also used to produce radioisotopes that can be used for medicine or industrial processes, and also in producing weapons-grade plutonium. Despite having a great use case, there are always challenges behind operating a nuclear reactor. The safety of workers is one such major challenge. Getting exposed to nuclear radiation can cause serious life-threatening problems like cancer, which is often fatal. History has been an excellent example of how serious accidents with nuclear reactors can be. The Chernobyl disaster in 1986 is one such accident, causing a predicted death of 4,000 and several cases of cancer in people related to it. Similarly, many such accidents have taken place in countries like Japan, Russia, and more. Often, workers are not the only ones to get affected. The people living in the city become victims too, due to the radioactivity in nearby water and land from the actual reactors. Disposing nuclear waste is another major issue. While you can throw your household waste into a garbage bin, that makes its way to a landfill or a processing plant for further disintegration. This is not the case with nuclear waste. The waste generated from nuclear reactors is difficult to manage. This is due to its highly hazardous nature. Methods like incineration, deep burial, and recycling are used to manage these wastes. This leads to concerns regarding the health and safety of the wildlife and environment. Environment concerns and related factors are some reasons against using nuclear reactors for inexpensive renewable energy, and hence, some countries are reluctant in using them.